Hello friends, welcome back to C-Level Physics. My name is Srinivas, known to be B.S. Rao. In this lecture, I would like to explain uniform acceleration and non-uniform acceleration. Acceleration is a vector quantity, means it should have direction apart from magnitude and should obey triangle of addition, otherwise parallel of addition. Okay. So as it is vector, should have direction, right? If any vector is constant, means direction as well as magnitude must be same. So here also acceleration, if acceleration is uniform in the sense, acceleration is constant. Okay, as acceleration is vector quantity, the direction as well as magnitude of that acceleration must be same, constant. So that is what uniform acceleration, right? Suppose here see a particle is moving along a straight line like that. A particle is moving along a straight line. Okay. So at a t equal 0, what is the velocity? Suppose 10 meters per second. Right? At a t equal to 1 second, at t equal 1 second, what is the velocity? Suppose 20 meters per second. Right? Now see, in a time interval 0 to 1 second, there is some change in velocity of the particle. See, this is the path followed by the particle. So, at t equal 0 means when our observation starts, what is the velocity of particle? 10 meters per second. At the end of 1 second, what is the velocity of particle? 20 meters per second. Means here clearly there is some change in magnitude of velocity from 10 meters per second to 20 meters per second. Right? See the path here. Path is a straight line, means the direction of motion, means the direction of velocity is not changing here. Okay, one condition is satisfied. Now, what is the magnitude of velocity here? 10, here 20. Means there is some change in velocity. There is some change in velocity, right? Acceleration A equal to delta V by T, right? That is V minus U by T. V minus U by T. Am I right? Now that equal to what is V? Say this is U, initial velocity. When our observation starts, what is the initial velocity? U. When our observation ends, what is the final velocity? Let it be V. Am I right? So U is the initial velocity, V is the final velocity. So V minus U, 20 meter per second minus 10 meter per second by time. Time is here, in fact, t minus 0, that is 1 minus 0, that is 1 second. Am I right? 1 second. Am I right? So, what is the acceleration? A equal to 20 meters per second minus 10 meters per second, that is 10 meters per second. 10 meters per second per second. That equal to delta V by T. Am I right? See, per every second, what is the change in velocity in magnitude? 10 meters per second. Am I right? 10 meters per second per every 1 second. That equal to 10 meter per second by second. That is 10 meter per second square. In the sense, 10 meter acceleration is 10 meter per second square. In the sense, the change in velocity per each second is 10 meter per second. That is 10 meter per second by second. That is 10 meter per second square. Am I right? See, for every second, suppose here it is t, here it is delta V, here it is acceleration, that is delta V by T. Am I right? Suppose for every 1 second, what is the change in velocity? 10 meters per second. 10 meters per second. What is the acceleration here? A equal to delta V by T. Delta V by T, that is 10 meter per second by second. That is 10 meter per second square. Am I right? 10 meter per second square. Suppose for every half second, if I reduce time interval 1 second into half second and half second, suppose every half second, 1 second, half second, the acceleration must be, the change in velocity must be half of 10 meters per second. 10 meters per second. Right? Half of 10 meter per second. That is equal to, what is the acceleration? Change in velocity by time. That is half into 10 meter per second by half second. Half second. So half of cancel. Again we left with the 10 meter per second square of. Am I right? So here the particle must undergo equal changes in velocity in equal intervals of time. See, for every second, what must be the change in velocity here? 10 meter per second. Right? For every half second, what should be the change in velocity here? Half of 10 meter per second. Okay. If I divide this half second into 1/4 second into 1/4 second, that is for every 1/4 second, what should be the change in velocity here? That is 1/4 of delta V. What is delta V? 10. That is 1/4 of 10 meter per second. Again, what is the acceleration here? Acceleration in the sense A equal to delta V by T. This is what delta V by T. That is 1/4 of 10 meter per second divided by 1/4 second. That is 1/4 cancel, left with the 10 meter per second by second. That is again 10 meter per second square. See, if you observe, if any particle undergoes a change in velocity through an amount 10 meter per second every second, right? If that acceleration is constant, for every half second, the change in velocity must be half of 10 meter per second. For every 1/4 second, the change in velocity must be 1/4 of 10 meter per second, such that acceleration remains here in magnitude. Am I right? Every equal interval, what should be the acceleration in magnitude? 10 meter per second square, 10 meter per second square, 10 meter per second square. What about the direction? Direction. See, this is the direction of velocity, this is the direction of acceleration also. Right? So here, direction not at all changing, magnitude of velocity also not at all changing, provided if it undergo equal changes in velocity in equal intervals of time. Right? Then that is what uniform acceleration. See once again, if any particle moves along a straight line such that it undergoes equal changes in velocity in equal intervals of time, then that particle is said to be under uniform acceleration. Here path must be straight line. Why? Because uniform acceleration in the sense constant acceleration. As it is vector quantity, direction must be constant. Means direction of motion must be constant here. That is straight line. So if any particle moving along straight line, maintaining equal changes in magnitude of velocity in equal intervals of time, then that particle is said to be moves with uniform acceleration. Uniform acceleration. Right? Now what about the conditions here? Uniform acceleration in the sense path must be straight line. Path must be straight line. Path must be straight line. What about velocity? Velocity is it constant or not? Velocity is not at all constant. Why? Because here there is appreciable change in velocity here every case. So therefore velocity is not constant. Not constant. But change in velocity, change in magnitude of velocity, that is change in speed. Change in magnitude of velocity in the sense change in speed in case of straight line motion. Am I right? That is delta V is constant, provided delta T also constant. Alright? That means to say that in equal intervals of time, particle must go in equal changes in speeds. Okay, moving along straight line. Okay, if in equal intervals of time, particle undergo equal changes in magnitude of velocity or speeds, then that is the indication of uniform acceleration. Am I right? Okay, so path must be straight line. Velocity is not constant, velocity is variable, but there is a change in speed or magnitude of velocity such that in equal intervals of time, the change in speeds also constant. Am I right? This is what uniform acceleration. Uniform acceleration. Now what about non-uniform acceleration? Non-uniform acceleration. Non-uniform acceleration means, see, non-uniform acceleration, by the name itself, acceleration is vector, but it is non-uniform, means not constant. not constant, right? Not constant in the sense, the magnitude of acceleration may be different, changes with the time. Otherwise, the direction of acceleration also changes with the time. Am I right? So here, change in speed or magnitude of velocity is not constant. Okay, that is delta V is not constant in equal intervals of time. See, a particle moves such that in equal intervals of time, delta T constant in the sense equal intervals of time. In equal intervals of time, a particle undergoes unequal changes in velocity. There is change in velocity, but that change in velocity is not constant, right? So in equal intervals of time, if you are observed unequal changes in speeds or unequal changes in magnitude of velocity, that is nothing but non-uniform acceleration. Otherwise, equal changes in velocity in case of unequal time intervals. See, however small these time intervals here. Suppose here, time interval is reducing from 1 second to half second plus half second. Again, each half second divided into 1/4 second plus 1/4 second and so on. So, however small these time intervals, the particle undergoes equal changes in speed in equal intervals of time, then that is uniform acceleration. Here, what is non-uniform acceleration? In equal intervals of time, a particle undergoes unequal changes in magnitude of velocity or speeds. Otherwise, in unequal intervals of time, a particle undergoes equal changes in speeds or magnitude of velocity. That is what? Non-uniform acceleration. Now coming to retardation. What is meant by retardation? Otherwise, deceleration. Sometimes particle may undergo retardation, right? Retardation or deceleration. Retardation, otherwise deceleration. What is meant by retardation and otherwise deceleration? Suppose if particle is acted upon by some external agent, something like force, suddenly its speed may decreases. Means it may slows down. Am I right? In that case, particle is said to be moves with deceleration. Otherwise, particle is under retardation. Means speed decreases by some external agent. So then particle is said to be under retardation. Right? So speed decreases with time. That is what retardation. Suppose acceleration. Suppose here this is the path of particle, right? At t1, what is the velocity? U. At t2, what is the velocity? V. Right? Now, what is the expression for acceleration? A equal to V minus, suppose t1 equal to 0, t2 equal to t as an example. Acceleration means change in velocity by time. Delta V by delta t. Suppose delta V means V minus U by delta t means t2 minus t1. That is t minus 0. That is V minus U by t. Here, U means what? Initial velocity. Am I right? Usually, initial velocity in the sense, velocity of particle when our observation starts. See, this is the initial instant at which our observation starts. So, at that time, what is the velocity U? That becomes initial velocity. When our observation ends, the velocity possessed by particle is said to be final velocity. Final velocity. Okay. Now, as particle slows down because of some external agent, final velocity must be less than initial velocity. Am I right? That is, V is less than U. So V is less than U. As V is less than U, definitely A becomes negative. So A becomes negative. A becomes negative. Right? A becomes negative. Okay. A becomes negative. Now, as an example, see the speed of particle changes from speed of particle changes from 20 minutes per second to 10 minutes per second in 2 seconds. Find its acceleration and retardation. Find its acceleration and retardation. Now let us see. What is the definition of acceleration? What is the definition of acceleration? A equal to delta V by T. Alright? That is final velocity minus initial velocity by time. Okay, that is A equal to. What is the final velocity? See, this is what initial velocity, this is what final velocity. Final velocity means somewhat less than initial. So 10 meter per second minus what is the initial velocity? 20 meter per second. Divided by time. What is the time interval to have that kind of change, that much of change? 2 seconds. 2 seconds. That is A equal to 10 minus 20 means minus 10 meter per second. Minus 10 meter per second divided by 2 seconds. That is minus 10 by 2 means minus A equal to minus 5 meter per second, that is meter per second square. Minus 5 meter per second square. This is what acceleration. A means acceleration. So this is what acceleration. Acceleration negative. Here acceleration is negative. But what about retardation? Retardation in the sense, take this negative sign to LHS, that is minus A equal to 5 meter per second square. This is what retardation. Retardation, right? So A becomes negative, means acceleration. Minus A becomes positive, that is retardation. Right? If you say answer with the positive sign, then that becomes retardation. If you say answer with negative sign, that becomes acceleration. Am I right? Okay. Now let us see. In fact, what is the direction of acceleration? Now let us see. Direction of acceleration. Direction of acceleration. Okay. Depends upon two factors. Direction of acceleration depends upon two factors. First one, whether it moves positive direction, otherwise negative direction. Okay, whether it moves positive direction or negative direction. So the direction of acceleration is characterized by whether it moves positive direction or negative direction. When do we say that particle moves along positive direction? Means V greater than 0, right? Velocity is greater than 0. Then particle is said to be moves along positive direction. Suppose when do we say that particle moving towards negative direction? Means velocity must be less than 0. Alright. Now second case which characterizes the direction of acceleration means whether particle slowing down, otherwise speeding up. Right? Whether particle speeding up or slowing down. Okay, whether particle speeding up, otherwise slowing down. when do we say that particle speeding up means both acceleration as well as velocity must have same sign. Both are either positive or either negative. See, acceleration, both acceleration and velocity must have same sign. Must have same sign. Must have same sign. Okay, right? When do we say that particle is slowing down means both acceleration and velocity must have different sign. Must have different sign. Both A and V must have different sign. Different sign. Suppose here first case, speeding up case, that is both are having same sign. Means number one, first option, A is positive, V also positive. Second option, A is negative, V also negative. So in both cases, see the sign, both are either positive or negative. So in these two cases, particle is said to be speeding up, means it is under acceleration. It is under acceleration. In these two cases, acceleration is parallel to direction of velocity. Means the direction of acceleration is in the direction of velocity or in the direction of motion of particle. In the direction of motion of particle. See, this is what path followed by particle. Here, 5 meters per second is the velocity. Here, 10 meters per second is the velocity. Okay, as time passes on, what happens? Velocity increases from 5 meters per second to 10 meters per second. See, this is what arrow mark, that is what direction of motion. Now, what should be the direction of acceleration means in the direction of motion of the particle, right? So, A bar is parallel to A bar. Now, coming to other case, slowing down case, both A and V must have different sign. That is, we have two options here. First option, both are different sign means A is positive, V is negative. That is, A positive, V negative. In second option, A negative, V positive. A negative, V positive. So in these two cases, particle said to slowing down. So in this case, particle is said to be under retardation. So what about the direction of acceleration? That is opposite to direction of velocity. So implies acceleration is anti-parallel to velocity. That is, the direction of acceleration is opposite to the direction of velocity, otherwise opposite to the direction of motion of the particle. So in this case, suppose this is the path followed by particle. Here, what is the velocity? 10 meters per second. As time passes, what is the velocity here? 5 meters per second. So velocity changes from 10 meters per second to 5 meters per second along a straight line as an example. Now what about the direction of acceleration here? Opposite to the direction of motion of the particle. This is what direction of motion. Now what is the direction of acceleration? Opposite to direction of motion, otherwise opposite to velocity. Okay, right. Now let us see some numericals. Suppose if S equal to T cube minus 6T square plus 9T, find the time interval. Find the time interval in which particle moves in negative direction. See, you are given S equal T cube minus 6T square plus 9T. Find the time interval in which particle moves in negative direction. Negative direction in the sense, if particle moves negative direction, velocity must be less than 0. See, we are given displacement, expression for displacement. See, S equal to T cube minus 6T square plus 9T. Now what about velocity? Velocity equal ds by dt. Velocity equal ds by dt. That is d by dt of s. So on differentiating this expression with respect to time here, 3t square minus 12t plus 9. Right? So this is what meter, for example, displacement is in meters. Now what about velocity? Meter per second. Meter per second. So this is what number 1, this is what number 2. Am I right? So velocity is so and so 3t square. I am differentiating, yes, with respect to time. We have 3t square minus 12t plus 9. Okay. If particle moves along negative direction, what about velocity? Velocity must be less than 0. That is, v is less than 0. V is less than 0. That is 3t square minus 12t plus 9 less than 0. Now here 90, of course. Okay, 9 less than 0. Now 3 is common here. T square minus 4t plus 3 less than 0. Am I right? That is 3 of t square minus 4t plus 3 less than 0 in the sense t square minus 4t plus 3 must be less than 0. So this is what quadratic expression, that is t square, on solving t square minus 3t minus t plus 3 less than 0. Here minus 4t means minus 3t minus t, that is minus 4t plus 3. So here t is common, t of t minus 3, here minus 1 is common, t minus 3, am I right? Less than 0. That is t minus 1 into t minus 3 less than 0. T minus 1 into t minus 3 is less than 0. So this is what required condition. If velocity is negative, that is, if particle moves along negative direction, velocity must be negative, which implies that t minus 1 into t minus 3 less than 0. T minus 1 into t minus 3 less than 0. Now let us check the time interval in which particle moves along negative direction. Am I right? By substituting different values for time here. Suppose here t equal to 0. Suppose t equal to 0. Substitute here. Somewhere here t0 means, in this expression t0 means 0 minus 0 plus 9. That is plus 9. Velocity is plus 9. Means velocity positive. Of course, from this expression also we can estimate the same. Why? Because t equal to 0. Substitute here. 0 minus 1 means minus 1. Means negative term. Negative term. That is velocity. Here t. Here velocity. Here velocity. T equal to 0. On substituting t equal to 0 here. 0 minus 1 means minus 1. That is negative. Here 0 minus 3 means minus 3. So negative into negative. That is negative into negative. That is equal to positive. Velocity is positive. Am I right? Next, t equal to 1. Suppose t equal to 1. I am substituting t equal to 1 second. T equal to 1 second. I am substituting t equal to 1 here. 1 minus 1, 0. 0 into something, 0. That is velocity is 0. 0 in the sense neither positive nor negative. Am I right? Next, t equal to 3 seconds. T equal to 3 seconds as an example. 3 seconds. T equal to 3 seconds means here 3 minus 1. 3 minus 1 means 2. That is plus 2. 3 minus 3. That is 0. 3 minus 3. That is 0. Am I right? So before that, I will check t less than, that is 1 less than t less than 3. 1 less than t less than 3 seconds. So 1 second less than, 1 second less than t less than 3 seconds. 3 seconds. See, suppose 1 second less than t less than 3 seconds means time is greater than 1 second less than 3 seconds. Suppose 1.5 second as an example. Here 1.5 minus 1, 1.5 minus 3. Right, that is 1.5 minus 1 means plus 0.5 plus 0.5 into 1.5 minus 3 means minus 1.5. That is plus into minus. Minus. Velocity is negative. Velocity is negative. That is plus into minus. See here, positive into negative. Positive into negative. That is negative. Velocity becomes negative. Suppose t equal to 3 seconds. T equal to 3 seconds. Substitute here. T equal to 3 seconds in the sense 3 minus 1. 3 minus 3. That is 3 minus 1 is 2. 2 into 3 minus 3, 0. That is 2 into 0, 0. Velocity becomes 0. Velocity becomes 0. That is, particle comes to rest at t equal 1 second and one more time at t equal 3 seconds. Am I right? Suppose t greater than 3 seconds. T greater than 3 seconds means t greater than 3 seconds. Suppose 4 seconds as an example. 4 minus 1 into 4 minus 3. 4 minus 1 plus 3 into 4 minus 3 plus 1. Plus into plus, positive. Plus into plus, positive. Velocity is positive. Now see, what is the required condition here? We have to find the time interval in which particle moves along negative direction. Negative direction in the sense velocity must be negative. See, 0 to 1 second. Velocity positive, but exactly at t equal to 1 second, velocity becomes 0 also. So behind that, from 1 second to t less than 3 seconds, velocity is negative. Means particle moving along negative direction. But exactly at t equal to 3 seconds, velocity becomes 0. 1 second particle comes to rest. Beyond 3 seconds, again velocity is positive. Same can be written somewhere here. See, t equal to 0 seconds. Okay. Now here t equal to 1 second, here t equal to 3 seconds. Am I right? At t equal to 0, what is the velocity? Positive. At t equal to 1 second, what is the velocity? 0. Here velocity 0. Am I right? So here positive, here 0 means velocity from here to there positive only. That is positive. Velocity is positive. Positive. Right? Exactly at t equal to 1 second, velocity is 0. Now from 1 second to 3 seconds, less than 3 seconds, this is what required condition. Our required condition is somewhere here. That is, if t is greater than 1 second and less than 3 seconds. Greater than 1 second, less than 3 seconds. What is the direction of motion? Negative. So velocity is like that. Velocity is like that. Negative. So here it is negative. Am I right? Beyond 3 seconds, again positive. So beyond 3 seconds, again positive means this is the velocity. Positive. Right? Coming to next numerical. This time you are given expression for velocity, that is v equal t square minus t meter per second. Find the time interval in which particle retards. That is, a and v must opposite side. Okay. See, velocity v equal to t square minus t meter per second. On differentiating velocity with respect to time, you will get acceleration. So a equal to dv by dt, that is 2t minus 1. 2t minus 1. On differentiating this one, you will get 2t minus 1. Now, retardation in the sense, both a and v must have opposite sign. Means velocity is less than 0. V less than 0. V less than 0 in the sense, t square minus t less than 0. That is t of t minus 1 less than 0. T of t minus 1 less than 0. Now let us check for different values of time whether v and a having opposite sign or not. Okay. First of all, I am taking time here, velocity here, and acceleration here. Am I right? Okay. Right. Now what about time 0 seconds initially? 0 seconds. Substitute here. Time 0 means 0 square minus 0. That is V0. V0. Otherwise you can realize from here also. Substitute in this expression. In this expression. So 0 into 0 minus 1. Okay, 0 into 0 minus 1, that is 0 into something, that is 0. Okay. Now what about acceleration? I am substituting somewhere here a equal to 2 into 0 minus 1, that is minus 1. Minus 1 means negative, so a negative. Now coming to t equal to t is taken such that greater than 0 and less than half, that is 0 less than t less than half second. 0 less than t less than half in the sense, suppose value of t such that lying between 0 and half. Between 0 and half means, for example, 0.2. I am taking 0.2. Substitute here in this expression. 0.2 into 0.2 minus 1. That is 0.2 into minus 0.8. That is positive into negative. Plus into minus. Plus into minus in the sense, plus into minus, that is minus, means velocity is negative. Now what about acceleration by taking 0.2 for time, that is 2 into 0.2 minus 1, that is 0.4 minus 1, that is minus 0.6, means acceleration negative. Acceleration negative. Now coming to third case, t equal to half second, exactly half second. Substitute here for in this expression, that is 1 by 2 into 1 by 2 minus 1. That is 1 by 2 into 1 by 2 minus 1 means minus 1 by 2. Plus or minus? Minus. So velocity is negative. Now what about acceleration? What about acceleration? A equal to 2t minus 1. What is t? Half second. 2 into half minus 1. So 2 to cancel, 1 minus 1, that is 0. So what about acceleration? 0. Okay. Now t is taken such that greater than half second and less than 1 second. That is half less than t less than 1. So t lies between half and 1 means lies between 0.5 and 1. Say 0.6. 0.6 into 0.6 minus 1. That is 0.6 into minus 0.4. Plus or minus? Minus. Velocity is negative. Velocity is negative. Now take somewhere here acceleration. A equal to 2 into time 0.6. Such that lies between 0.5 and 1. I am taking 0.6. That is 2 into 0.6 minus. That is 1.2 minus. That is plus 0.2. Means A is positive. A is positive. Here no need of values. Simply we are taking signs for velocity and acceleration. Right. Now question is to find time interval in which particle retards. Particle retards in the sense both A and V must have opposite sign. Must have opposite. See here 0, here negative. 0 means neither positive nor negative. But here negative. Here negative, here also negative. Means both are negative sign, means same sign. Acceleration. Here acceleration, not retardation. But here third case, velocity is negative, acceleration is 0. 0 in the sense neither positive nor negative. So this is also ruled out. Coming to this interval, exactly this interval. See, this is the interval. Velocity is negative, acceleration is positive. What is that time interval? Time is greater than half second and less than 1 second. So during this time interval, velocity is negative, acceleration is positive, means as both are having opposite sign, in this interval particle is under retardation. So this is the answer. This is the answer. Okay. That is in between half second and 1 second. In between half second and 1 second, particle is under retardation. Okay. Thank you, friends.